Part C, let h of x be this function, a new function now, is to find this integral from x to 3. I do want to point out that f is now suddenly h prime, not relevant to this problem, but just pointing it out. We want to find all the values for x for which it's going to equal 0. H of x is going to equal 0. So now we just got to think about how to interpret integrals and what kinds of things can happen. One of the things that I hope is obvious, it's one of our properties, is that if you integrate a function from, like, you don't move at all, the x's, then the area under the curve is 0. So if I start at 3 and I end at 3, then there's no area at all, it's 0. So h of 3 is definitely a place that's going to equal 0 just because of the way integrals work. There's another value that works, so what I want to do is kind of think about what this means. We're going to integrate from some random x value up to 3. So here's where 3 is, right? And wherever else I start on this curve, if I start over here, I'm going to integrate from here all the way to over there. Oh, I missed one. My answer's wrong. I just found another one. My key's off. Yeah, so it's fun to see, right? Let me start with the one that was clear to me. I know that if I start, I'm not going to go to the right of 3. I'm not going to look at any x values over here because the function is not defined. We're looking between -4 and 3. So I'm looking somewhere to the left of this x value, and I basically want to find a place where the areas would cancel out. So to attack this problem, that's what I was thinking about. I want areas that'll knock each other out. And so as I start to look at that area and go this way, I have the area of this triangle here. As I continue on in this direction, I can see that I've got these two congruent triangles here. One's above the x-axis and one's below. So at this point, these areas would cancel each other out, and that happened when x was equal to 1. So I'm pretty sure h of 1 is also going to equal 0. And I got lazy. I should have kept going. So if I keep going to the left, and I keep going, so if I were to integrate from here, all this, and all of this, and all of this, and all of this, well, all these areas would also cancel each other out. And that happened when x was equal to -1. So that'll be a third answer that I missed. If I continue to go to the left, this is just going to continue to make the answer more and more and more negative. So I'm confident that at this point I'm done with the problem. I had to think about the areas under the curves and just look for places where the areas would cancel each other out. And I had to imagine starting at 3 and moving my way to the left to find congruent shapes with equal areas. But half would be above and half would be below the x-axis. So that's fun.